why we're actually asking and very much interested is you'll see throughout this hands-on workshop that you have actually just seen the fact that we have started with a simple pipeline, with the starting pipeline. And this is what we're going to do first. So first, we're just going to get you familiarized on how how the pipelines are being created, how the initial scripts are being created, and then get a bit more into the more advanced parts of basically doing CI. So that is great to know. Really love the 6% of the people capturing and analyzing DORA metrics. That is always so fun, and it's super nice to hear that people are also into analyzing and tracking, and of course getting an improvement there. So that is good. So we're still rolling out a few users, but we can move further. Would have been better if it were multiple answers questions. Yeah. Perfect. So from what I would want to point out for now for this hands-on part. So from what I understood from Logan is basically the fact that we're going to have the instructions for this workshop after you have, of course, opened your project. You'll find the instructions under issues. So, for example, now we're doing the simple pipeline part for today's workshop. But for those of you who aren't able to see the instructions under the issues, there's another way that you can actually get to this part of the instructions. So if you're not able to see anything under the issues, these exercises for today, you can still see them by navigating to the project, courses, workshops, and for today, we're doing the CI/CD workshops. And basically, by opening these markdown files are exactly the same exercises that we'll be doing in the issues. So this is basically the navigation that you'll need to take, just in case you're not seeing them from under the issues. So there are a couple of places that you can go to and reference on how we're going to cover for today. So without further ado, let's go on and start getting our hands into these parts. Let me just take away the slides for a little bit because we won't be needing it. So the way that we're going to do this hands-on portion of today's workshop, we will be doing all the steps live. So you're more than welcome to follow along. But if you get stuck or fall behind, don't panic. We still give you a couple of minutes after each of the sections so you can catch up. Of course, last but not least, you'll be able to do this afterwards in your own time, as you will still have access to these environments until May 5th. So without further ado, let's start. So what I'll be doing is I'll be splitting my screen. Let me just open up the project in another tab. So I'll be keeping them separately. I'll be doing my Learn Labs instructions on the right-hand side, and I'll be doing my project on the right-hand side. Perfect. So first exercise, simple pipeline. Now, this challenge will walk through the steps of importing your CI/CD pipeline project and creating your basic pipeline. So now that majority of us hopefully have a project imported, notice that we do have a simple pipeline which is already defined, and this is where you will be able to see it in the GitLab CI YAML file. We already do have a YAML file defined. We have already 2 stages, build and test, as well as the build stage, which includes a before script and after script. So these were the scripts which we have been previously touching on. So what we need to do next is the fact that in the test job, we also want to include an after script keyword to echo out that the test has been completed. So in order to do so, we first need to go ahead and edit our pipeline. And we can definitely do that. Let me just expand this a little more so we can see it better. Perfect. So right here on the top, we do have the edit button where we can go ahead and edit in pipeline editor. So what we're going to do is copy this after script and paste it right after our test stage, our test job, sorry. Now, the test job should look something like this. Keep in mind that throughout this entire workshop, you will actually see sections that look like these. So these are sections which are meant to, that you can use as a reference for you to just compare to where you are, compare to where you actually need to be. If there's something wrong, you can simply delete the entire portion and simply copy this particular part in the clipboard and use it just to make sure that you're on the right track. Perfect. Now that we have added our code, we can go ahead and commit the changes, which is going to immediately trigger the pipeline. The pipeline would run, ideally with no issues detected in the YAML file. And in order to be able to see how the pipeline is running, we can navigate on the left-hand side to build pipelines. And in order to open a pipeline, we need to click on the hyperlink, this one with a hyphen, of the most recently run pipeline. So again, this is just our simple pipeline. This is our basic pipeline, which has both build and test into them. You can also feel free to click onto the test job as soon as it's being finished to see the output and to, of course, see be on the lookout for the message that we have been echoing out. We won't be sitting around until this pipeline is getting finished. But just in a few minutes, I'm sure it will be done and we can always trace back to it and take a look if it was successful or not. But in the meantime, I propose we get to step 2 and ask GitLab Duo. So I'm not really sure if you're familiar with GitLab Duo, where GitLab Duo is basically embracing the AI capabilities that GitLab has. So how can it be useful? For example, if we wouldn't know where to find our running pipelines, or if you wanted to learn more about the image or the keywords in the pipelines above, well, we can use the new GitLab Duo chatbot to do that and even more. So there are 2 ways in which we can access the GitLab Duo functionality. One of them is the one which is being described here. To go back to our navigation pane, help button, and enable GitLab Duo chat. But there's another way that we can engage GitLab Duo chat is also at the top right here. You also have this Tanuki icon, which is going to prompt you with the GitLab Duo chat. So this is where we can potentially ask what CI/CD keywords can I use in GitLab? So for the rest of the workshop, you can eventually use this chatbot to ask as many questions as they may come up. You can even ask it coding questions if you get stuck. So feel free to interact it throughout this entire session. Now, I will give everyone a couple of minutes to complete this exercise. So it will be just some minutes of silence. Please, of course, if there are any questions, and if there's anything that you would want us to assist with, you can find us in a chat, but just a few minutes so you can all catch up on the exercise. When you're ready to go, if you could please give a thumbs up in the chat so we will know. Perfect. If it's all good, let's resume. I'll just get back to our presentation for today. So happy that we got everything going. First exercise went rather okay. Could have been better, but it eventually runs smooth. I hope everyone is okay. Lab number 2. So we did complete our simple pipeline. We have a good base, and we are now going to try to add some of complexity to it. You'll notice that every single lab from here out will be building off that starting pipeline that we have just ran through. So we will be building into a true advanced pipeline in the end. So lab number 2, after showing off your simple pipeline to the team, they really loved it. But they were wondering if you could speed up the process a little bit. So you decided you're going to show off your skills and show how you can create a pipeline with different execution orders, as well as a large tag to show what is really possible. Execution order is basically the biggest thing that can increase your pipeline speeds. So a number of tests you're running probably don't have to wait for things that run before. So I'm thinking specifically code quality, for example. Code quality is not really dependent on what you're actually building out of your application. And so that's where you can use execution order to have those things kick off right at the start and not have them run sequentially by adding more time to the pipeline. So the default behavior is that the job in the next stage will start after all the jobs in the previous stages have completed successfully. However, we can adjust this. As you can see here on the screen, we do have the desired state, the super fast test, which does not need to result of a build so it can execute at the same time. So with this, we have what we call the needs keyword, which basically allows us to specify what job we would need before it is going to execute. So you can basically build dependencies on your different jobs. And by changing needs and adding needs with, of course, the empty brackets, it means that it doesn't need to do anything. So it can execute immediately. So what you see here is what we can execute different jobs, even if they are on different stages at the same time, which is allowing us to speed up the process of the pipeline and making, of course, more efficient. What you can also do is to create more advanced needs. And this is where we go into direct acyclic graph, or DAGs, where you can actually create those dependencies between the different needs. So you can say that a specific build, for example, build A, once it finishes, it doesn't have to wait for build B. It can immediately start with testing A because the test has been finished. So with this you can actually achieve with a DAG. And on the right, we actually explain on how you can do that. So we do have it is quite complex, and we'll be very hands-on with it soon. So don't worry, we'll cover it in a few minutes in the workshop. And we'll actually show you an example on how you can use it on your project. Perfect. Now, stages pipelines. Let me just see, there's something a bit odd with what's going on. Let me try to reshare. Just give me a second. Apologies for that. It was something a bit acting up here. I don't know what. So stages pipelines, it means that basically you can run everything in a single stage, as the name states, or no stage at all. So it allows the needs keyword to be used in the same stage. Previously, you could only use it between different stages. Some of the advantages of why using a stages pipeline, well, it's more efficient, it's faster to write, it has less cycle time and less minutes on your actual runners. All right, let's go ahead and continue with our workshop instructions. I will give everyone a few seconds to jump over the current lab setup. I'll be doing the same myself, of course. So dragging and dropping everything in. Perfect. Second exercise, you can either find it under issues, the second issue, either find it in the repository. You have the navigation for the repository in the chat a bit up. So this challenge will build off the simple pipeline that we created in the first track and show you how you can modify the execution order and create a DAG. Now, if you're coming from the last track, you should still be on the pipeline page. In my case, I'm in the GitLab Duo page. If I close it, I'm on the pipeline page. So what we need to do is basically go on and see. Of course, our pipeline right now has completed, as I mentioned. It took a bit of a minute. We can quickly, this is part of the first exercise, but why not go through it now? We can also see how our echo has run. So everything is in place. Everything has run correctly. Now, what was important to actually mention is the fact, and to see, was the fact that our jobs have actually run sequentially. So what we would want to do now is to edit our pipeline in order to make sure that we have a test job running. After the test job, we should have another job, which would be the super fast job. So let's go ahead and enter that. So to do so, I'm navigating to my left pane, go to build, pipeline editor. So what we're going to do is we're going to add the super fast test job right below our test job. So copied it, and it's right now pasted. Now, we have two jobs. We also want to modify the execution order so that they run at the same time. And to do the following, we of course need to add the following line at the end of the test code block. So right at the end of our test code block, we need to add a needs, of course. The new test job should look like this. So this is a snippet just to compare how our new test job should look like. The next step is we can go ahead and commit the changes. And then we can go ahead and take a look at the most recently kicked off pipeline. We can do that by going back to the same navigation, going to the sidebar, build, and go to pipelines. And the latest pipeline that has kicked off, it is right now running both on test and build. We can go ahead and click on that. And of course, we're going to see our different stages. So right now you can see that under the test stage, we have both test and super fast test. And what you actually notice is the fact that the super fast test, it really went, the first one, it really went because it didn't need anything else. So that is actually the purpose of including the super fast test job. So success with that. Perfect. I think it would be good to also see some of the dependencies. So for now, this is a different tab that was previously open, but we will touch on it really soon within our next part of the step 2 today, the DAG, directed acyclic graph. So now what if we had many stages and relationships between the jobs we wanted to run as soon as possible? So how we can accomplish this using the DAG? So what we can do is of course, add a new stage. So let's go ahead and do that. Navigate back to our pipeline editor. So what we want to do is to add an extra stage, array stage, to our list of stages. So we do have build, we have test, and let's also add race. Perfect. Now we have defined the stage. We also need to take it a bit further. Now, below are the jobs that we want to add under our super fast test jobs. Now, there are quite a few, so definitely use the copy to clipboard functionality for this. As you can see, we will be adding quite a lot. So make sure to copy all this information, and we need to add it right under the super fast test job. Let's go ahead and do that. Perfect. So for now, we can also click on the Visualize tab. Since we have entered all this information, there is a way that you can eventually visualize how complex and how many stages we have here. Going back to the edit part, let's go ahead and commit our changes. Our pipeline is right now kicking off. Perfect. We have it up and running. So if we go ahead and take a look at the pipelines, you already know the drill, I think. We can open our pipelines and eventually see how our pipeline looks like. Well, this is quite a lot. And this is where the job dependencies actually kicks in. So if we want to actually show them, you can basically see an actual representation of the flow being defined here by our needs. So the same way we can actually take a look, and if we hover on any of them, we can eventually see the dependencies between them. So for example, test car C is dependent on build car C, but race car C is also dependent on test car C as well as build car C. Even more advanced, it's also the needs part, which is more graphical. So this is also going to give you a bit of in a more graphical way, the same amount of information, such as how the dependencies work between them. Obviously, build car A, test car A is dependent on build car A, and race car A is, of course, dependent on the test car A. Now, I hope everybody has been able to finish off this exercise, or there are no issues. I'll still, again, give you a couple of minutes to still complete it, just in case there's something wrong. So again, just a couple of minutes so you can all catch up with this exercise. When you're ready to go ahead, please, if you can give a thumbs up in the chat, we much appreciate it. Perfect. One quick mention, because I see that there's some questions happening in the chat, the webinar chat. If there are questions related to the actual course, of course, please use the Q&A session, because it's much easier for us to keep track of them. In this webinar way, it is a bit difficult to click on a specific reply, so we're kind of it is possible that we're missing answering all of the questions, so it's much easier to use the Q&A. So we'll know that we're tracking each and every one of them. Thank you for that. Perfect. Let's move forward. Since we have already completed 2 exercises, I think it would be good to actually go ahead and do a 3rd poll, which I think it's important, to know how you're feeling about the pace of the workshop so far. Are we going too fast? Are we going too slow? Is it okay? Are you lost? If you're lost, please shout out. We'll be more than happy to help. Okay. Yeah. Whoever is lost, please jump forward. We'll need to rescue. We need the rescue. We also have a rescue team here. Okay. Perfect. Thank you. I think that majority of the people are just right. We will try to buy the votes. We will try to do it a bit faster, a tad faster. Perfect. Let me just close this off. Now, last but not least, caching rules and failures, lab number 3. Now, the idea here is that we have an execution order. Now, you saw how we can create a kind of complex web of different jobs that can run to eventually create the ecosystem for you for deploying your application. What if we added some more gates to some of the logic? For example, if a test fails to this, if we're trying to deploy to our production environment, actually run this test instead. So again, adding a bit more complexity and a bit more logic. And that's what we're going to be covering throughout this entire section. And additionally, we'll talk about caching. So of course, caching is the greatest part that we can basically speed up your application. Lab number 3. So as you come back to the team and show them how your new pipeline, your team asks if you can make the pipeline faster and make it more resilient. Now, you know GitLab can enable caching throughout its runners and S3s. So to set off, let's go and do that. Caching basics. Well, the GitLab runners will take the content you cached and store it into S3. This is particularly useful for when you're using, for example, some node modules, which you can take ages to load. And of course, you need to be going to cache them. So you have here on the screen, on the right-hand side, the diagram where we have 2 stages, build and test. We also have a default job that will run for both of them. So we're going to build out the build cache and storing what is currently on the vendor path. So the execution order is as it follows on the screen. First of all, the pipeline runs, job A runs, then the cache is being extracted if it has been found. The before script is being executed, the actual script is being executed, the after script is executed, the cache runs, job B runs, the cache is being then extracted again if it's being found, the before script is being executed, script is executed, and last but not least, pipeline has finished. So it may seem harsh, but it's pretty straightforward. And again, the diagram here on the right is very much clean and self-explanatory, I would say. Now, why would you cache? So you can share downloaded content between jobs, even across branches. You can also store code dependencies, so you don't have to wait for them to load the next time. And last but not least, and you can even increase the pipeline run, so you can increase the speed even more. Now, this is a nice question. Cache or artifact, which one is it? So this pops up quite a lot on why and which one would you choose, one or the other. So I think that the main difference is that if a job isn't actually reliant on another job's outcome. So for example, if job B doesn't have to rely on job's A output, you can cache, because the goal is you're just trying to speed things up. And it would run faster if it had access to the output of A, but it doesn't necessarily need the output to fully function. Or reverse, for example, if job B is fully dependent on succeeding from the output of job A, that's when you would basically be using artifacts. So in a nutshell, cache is here to speed up your job, but it may not exist, so don't rely on it. Now below, you have here a link, which is basically helping you. It dives deeper into GitLab caching. I will also post it right here in the chat. Allowing job failure. Well, we need to find a way to configure the pipeline so that even when a unit test fails, we want to continue the pipeline. So we don't want it to basically stop the full pipeline from continuing to execute. Now, for that, we have a keyword which is called allow failure. And by defining it to true, we're actually going to allow the job to fail. So it's basically going to be locked, but it's not going to prevent the subsequent jobs from executing. This is a very important mention that we need to have. Now, you can use rules to include and exclude jobs in the pipeline. So rules are being evaluated when a pipeline is being created and evaluated in order for the first match. So for example, when a match is found, then the job is either included or excluded from the pipeline, depending on how it is being configured, of course. Now, you can also combine the keywords to create more complex rules, but let's take a look at some of the most common examples and most useful examples, of course, into the next slides. So when is a job not created in a pipeline? If there's cases where you do not want a job to run, you can exclude them from the pipeline by using when, and of course, giving the parameter never. So it will never run, basically. You will also want to include this with a rule evaluation, for example, as part of a statement, as an example, which is right here on the right. Otherwise, it will never run. So here are some rules when a job is not created in a pipeline. What you can also do is you can use when manual. So when manual will basically require you to do a manual action before it's being executed. So for example, in the screenshot, you can see that the deploy stage has a when manual rule being enabled, which requires me to go into the pipeline and click on that little play button to have the deployment happening. So one example of a use case for this is, for example, when you want someone to just audit the success of the pipeline, even when you have more complex jobs running. And this is, for example, when you would want to use allow failure. You can also have this manual step for someone to go in and check that failure. So this is just an example of a combination where you can use when manual together with allow failure. When, so if a rule evaluates, it's true. And when it has any value except for never, the job is basically included in pipeline. However, if you use when with the parameter delayed, so when you use when delayed, it means that it's going to be added, but it's going to run in 2 hours, for example. So it's basically the time frame. It is being defined by the start in value that is also required. Now, a couple of more examples to mention. If a pipeline source is being merge request for a scheduled pipeline, then the job is being executed. Or if none of these criteria are met, it will not execute. Another example here is using changes and if. So in this scenario right here, if a specific variable has a specific value for the job, it will be included. If there's any changes to the specific files, and of course the when is going to be manual, so it means that the job will be added, but it also means that it needs to be manually triggered. And last but not least, of course, again, a lot of talk, a bit more hands-on part, the fun part, caching rules and failures. Again, I'm going to give you a few seconds to go back to your exercises. I'll do so with mine as well, moving some screens around. Perfect. Going back under issues, third exercise for today. Now, in this challenge, we will take our existing pipeline and modify it to show how useful GitLab rules and the allow failure keyword can be. Now, first, we need to reset the existing pipeline from the previous track because we have done quite a lot of heavy work duty with all of those code blocks. So the first step, what we're going to do is we're going to remove that big block of code that we have just entered before. So in order to do that, we navigate to our sidebar, build pipeline editor. And first things first, we need to remove everything from our YAML file right after the super fast test. So we need to remove this part with the build car A until the very end. Oh. Perfect. Everything else can stay as is. We, of course, need to also fix the stages because we don't have a race stage anymore. Let's go ahead and delete that. And now to ensure that we're back at the same point, here is what your code in YAML should look like. Again, that comparison, that reference part, we just need to compare where we are with where we should actually be. So if we're double checking, everything looks fine for now. Perfect. Now that we have reverted to our initial state, it's time to add some rules. So let's start with the basic one to do our test job. So let's say we only care about if the job is running, if it's being merged into the main. So that's a tricky one. So to do this, we need to add a rule definition defined below to the end of the test job. So let's go ahead and do that. Right after our test job, we are going to add this definition, which is basically telling us if we're committing to the main branch. This is basically an extra logic to take it into consideration. Now, before committing the changes, we're going to add cache and also allow failures in the next steps. So we saw after committing our last change that the pipeline does take some time to run. Now, our next few pipelines are built off the current configuration. So we don't want to add any caching for the vendor Ruby, gem file lock, so that they don't have to be pulled on the next time. So let's go ahead and add the code below, right up under our image definition, so that our node module would be cached. So again, taking the instructions, copying them to the clipboard, and we need to insert this part right under the image definition. Now that this code is added and the shared runners will cache this information into our GCP cloud storage for us to pull next time we run the pipeline. And we're not done and we're not yet to the committing part because we still have step number 3, adjusting for failure. So what if our super fast test job had been failing? Now it will be fun to replace this existing script echo and of course return 0 with a new line to actually make it fail. So this is going to be an interesting one. Need to navigate to our super fast test. And what we need to do is to replace our existing script. So we're going to remove our existing script from what we have now. And only add exit 1 to it. What if we also wanted to allow failure on a rule that had on a rule that we had set? So let's test it for the super fast test job as well. So let's add an additional rule. So after the needs, let's go ahead and add this rule as well. Perfect. Now, again, the YAML file for the superfast test and unit test should look something like this. We need to just simply double check if everything is in place. Now everything looks fine. And we can go ahead and commit the changes. Perfect. Changes have been successfully committed. We're waiting for our pipeline. It is checking the status. But in the meantime, we can go ahead and navigate to our pipelines and click on the hyphen with the most recently run pipeline. Now, the thing is that in the pipeline view, we can also go ahead and click into each of them and see how our added rules of allow failure have been changing the output. We should also see that the super fastest jobs will be failing with a warning. This would be, of course, taking a while. This is the part where I was talking about before with the color coding. Oh, you see, has already popped up. This orangey yellowish part where it's actually failed, but we have been allowing this failure. So this is where we are allowing the failure, which is still okay. The pipeline is still running. So I think that this was an interesting addition. So with that, I think we're right about halfway through our learning labs for today. The idea was to give you a few minutes to also finish this exercise. But since we're basically halfway through, we do have a major pit stop going forward. Okay, the color is called amber. Thank you, Marcel. Appreciate it. I'm not very good with my colors. We do have a major pit stop. So in 10 minutes, be sure to be back and we can continue with our workshop. Nope, 10 minutes. All right. So I hope everyone had a nice break, caught up with the exercises, maybe had a drink refill, coffee refill, water refill, maybe some snacks, why not? And ready to continue. So we got just about halfway through today's session, and we still have about 1 hour and a half left. And with that, Martin is also here. Martin, can
Hi,
take it.
thank you, Gabrielle. Let me just share my screen. Okay, not that screen. So I want to share that. Okay, so first of all, can everyone see a slide that says templates and artifacts?
Yep, we can see it.
Got that. Thanks, Gabriella. So, hi everyone. So, welcome back. What's that all about? Okay, so we're gonna dive into the next part of the workshop here. So just to quickly recap on what Gabriella's done so far and where we're up to. So we had a bit of a quick intro into what our CI and CD pipelines are all about. We got our hands dirty with some labs and managed to trigger some pipelines, started some pipelines. Then we got into the realms of looking at things like execution order and acyclic graphs and how we can really kind of optimize our pipelines for what we need to do. And of course, we should always be thinking about ways in which we can optimize performance, not just for kind of speed performance, but also for readability, usefulness. If we're sharing this around amongst our peers and our colleagues, does what we're crafting actually make sense? So that's an important thing to bear in mind as well. We looked at caching rules and what we do with failures. And what we're going to do now is really kind of extend the theme around reusability, first of all, via templates, and then also how we can use artifacts and remind ourselves of where artifacts come into the picture and how they differ from using a cache, for example. So first of all, let's get into the realms of why we're doing this. So this is lap 4. So the team like our pipeline, that they like what we're crafting. It looks good. It makes sense. However, they become aware of the fact that there are some additional bits of functionality that are useful to us, particularly around things like security. And maybe, if we are able to kind of produce artifacts as part of our build jobs, can we actually get them into a position where we can download those and reuse those further down the line, perhaps for another job? So let's have a look and see what we can do with templates. So in the essence of reusability, modularization of trying to, reducing the whole, don't repeat yourself and having teams, duplicating functionality across different teams that effectively does a similar thing. Why don't we as organizations concentrate on standardizing functionality for certain tasks and certain jobs? So as an example, if I'm building a Spring application or a Spring Boot application in a certain way, if I know that teams in my organization are doing the same thing, why don't we just try and standardize on the way in which we do that and have that as a reusable piece of functionality that can be consumed by the other teams in your organization? So what this means is that we've got a handle on anything that we need to do from a kind of legal perspective, a compliance perspective, and it also frees up developers to go and concentrate on writing code and doing the interesting stuff that they find interesting rather than doing stuff like CI/CD pipelines. So templates are one of the ways in which we can do this. So they're nothing magical, as it says there. It's a way in which we can share functionality within our CI/CD realm. It's the way in which we can consume pre-existing templates functionality within inside our organization. It's a way in which we as GitLab, and you'll see this in the labs, we provide functionality as part of our engineering effort. So, for example, we provide templates for doing things like security scanning, etc. They're nothing magical. So, everything that you've seen so far in your CI/CD files is pretty much what a template is right now. So, as long as we can use them and we're visual with them, we can consume them in our projects. The way we do it it is via an include mechanism that we use inside our CI YAML file. More on that shortly. And based on any rules that are defined inside those templates and the values on any things like variables, for example, those rules can be created and those jobs can be created or not, depending on how we've specified that functionality. So templates. Here's an example of one where it's possible to include a template to bring in our SAST scanner that we have. So if you've got Ultimate Premium from GitLab, it's possible to use this include mechanism here in your CI file. So on the right there, the code snippet is basically doing this include. It's including a template and it's including that location there, that SAST GitLab CI file. And you'll see as we get into the labs and as we get into the editor, we are able to visualize what that tree looks like, what it's bringing in, and we can actually go down to drill down and see the original YAML where it's actually pulled from. So they give us this feature where we can use those and import them into our build pipelines as and when we wish to. So there's different ways in which we can bring templates and use includes inside the platform itself. So first of all, this include template is a way in which we can bring in content that's been provided by our engineering team. So for example, the SAST one that you just saw. Include file, which is a way of bringing in a YAML file which is located in a project in the same group hierarchy as our GitLab YAML file. So in that particular example, we're bringing in the file GitLab CI YAML template in the templates directory from the project, my project in my group. As long as that project is in the same hierarchy as we're calling from, then we are able to bring in that template and to bring in that include file. Include local is bringing in a file from the same project repo as our GitLab CI YAML file. And in that particular example, we've got a templates directory with that YAML file inside there, and we just do an include local. And then we could also do an include remote. So this completely references a publicly available project repo and brings in the YAML that way. So the considerations here is really where does this stuff sit? Where should it sit? And the other teams that are consuming this, what level of visibility should they have into your world? So it's really down to you to think about the best way in which you can distribute these common jobs and these common pieces of functionality. So that's templates very quickly, and we will get hands-on with those shortly. What I will say, just to remind us that this is all about reducing the need to duplicate functionality. They're great. They're useful if you know where to look for them. If they're described in such a way that's useful to you, then our templates can become more powerful. So what we can do is in a piece of functionality that is emerging from our world is CI/CD components in conjunction with our CI/CD catalog, which we'll see shortly, which is really taking templates and making them more useful, frankly. So what we can do is we can do things like pass in parameters to them. We can treat the actual template itself as an application and have a build pipeline around it to validate that the template and the actual things we're creating are going to be useful to us. And we could also version what we have as well. So we can use semantic versioning. We can release different versions of our components and make these available. And teams can bring in the appropriate version as and when they wish to. What we can also do is make these things more discoverable. So how do we take these templates? How do we take these components and then place it into a location where it's searchable by users of the actual GitLab platform itself, or also maybe from elsewhere? What if we want to be able to interrogate a catalog, for example, and find out what's happening and what's available to do the job? So we have CI/CD components, which we will have a look at shortly. We have also currently in beta from our world is a CI/CD catalog. And this is really a location in which we can go and look up our CI/CD components that we wish to consume. So based on information that we provide in the component project and some metadata about that particular project, we can find out what it does, what parameters it expects, and also put it into a format where it's presentable with inside this CI/CD catalog here. So what you'll see shortly is that the effort around this so far on GitLab.com is really around open source contributors and others that have put together CI/CD components, and then they publish them to the actual catalog itself. What we will also have available is, those of you who are not using the SaaS version of our software, is an internal CI/CD catalog. So you can publish components internally within inside your organization. So that's a powerful thing where you've got discoverable, reusable pieces of functionality that are easily looked up and found within inside your organization. So this is quite an exciting piece of functionality as far as I'm concerned. So that's the CI/CD catalog. When we talk about jobs, so we've seen jobs so far, we've seen our build jobs and our test jobs and et cetera, that we've incorporated into our CI files. All well and good, but how about the cases where we want to actually customize any of the job behavior? So if I want to extend a job, for example, or if I want to override values and behavior when inside a job, how do I really do that? So there's a couple of ways in which we can do it. So we can extend template jobs and provide and then provide key value pairs in our local GitLab CI file to actually override or replace any of the values within inside the default behavior. Or what we can do is use environment variables to change behaviors based on values. So on the top right there, we've got an example of an extends of a template is extending a template that's come through probably from that included YAML file, and then we can add additional functionality inside there to override or augment or change what's in the template that we're extending. In the lower example there, in the secrets detection GitLab CI YAML file, we are basically we're providing variables that can be used to drive how that particular template behaves. So, for example, in the secret analyzer job there, hidden job, what we've got is this image, and then we've got a path. And then if we can just change the variable prefix or the secure analyzer's prefix variable, for example, at runtime, which we can do, we can change the behavior of how that template job actually works. So we can customize job behaviors. So you've got to think about, again, if you're including a template from another team somewhere and you're extending the behavior of this, it pays to have good documentation and notes and comments in your existing CI files that basically explain what it does, and if it is to be extended, how it should be extended. There's nothing worse than having a messy bit of code that you're trying to work out. It's always easier to have some good instructions on how to do that. And CI/CD components take that one step further, where it's absolutely explicit about what they take as parameters and what the actual job does as well. Okay, so that's options for customizing job behaviors. The next thing we'll look at is pipeline security, but really within the context of thinking about our variables that we have within inside a pipeline and how visible they should be within inside the running pipeline, and any artifacts that are produced from pipelines, for example, should they have any kind of plain text versions of any data that we think should be hidden, for example. So outside of doing our things like security scanning, so we'll see that shortly, where we can just include templates and SAST and DAST and anything else that we want to include as part of our build pipeline. We also want to make sure that the pipeline stays secure. So it's quite easy to do this with CI/CD variables, but we have to be careful with them because it's possible to store sensitive information which could end up in locations where you don't want it to be. So if we're storing low-risk secrets, we can mask them and protect the variables. If we're doing something a bit more hardcore and we've got things like keys and proper username passwords, and there's potentially rotation involved in those credentials as well, then we really should be looking at plugging into an external tool like Vault to do that for us. And then we can use an integration point from GitLab into Vault that allows us to pull those values as and when we need to. So really, we think about things like, start at the very top and try and keep things as secret as you need to. So what we have inside the our build pipelines, and you will see this when you run pipelines, and you've seen so far already some examples of variables existing in GitLab CI files. We have an order in which variables are processed. So looking at the middle section there, so we'll process values that have been defined for this run. First of all, values configured, then followed by values configured for the project or the instance. Then any values that have been inherited from jobs in any previous stages. Then we evaluate anything that's in the variables block in the YAML, and then any kind of predefined values from GitLab. So as a result of this sequence and the ordering of that sequence, we'll end up with the right values of the right variables at the right location in the CI file itself. So that's important to bear in mind. Other things that we'll look at are artifacts. So we can build artifacts as part of our build jobs. And remember, the difference between an artifact and a cache is that a cache is a kind of nice to have. If it runs, it's going to improve the performance of our build pipeline. If it doesn't run, it's not going to, the build pipeline is not going to fall over, and that's going to be the end of it. So whereas with artifacts, these are much more things about building stuff, putting it into a location where then it can be used downstream by another job, because the other job that's going to use it has got an absolute dependency on that artifact being there. So this is where artifacts come into play. And in this example, we've got this build app job. It's going to build some artifacts into that location there, that disk location, and we're putting an expiration time on this. So how long are we actually going to keep the artifact? When you run the job, you'll see that at the end of the job there, it will upload that artifact or any artifacts produced via that build into the location specified. And then we can also go into the job itself and select to keep or download or look at or browse and look at the artifact that has been created as well. So it's a good way for us to build stuff in a job, save it somewhere, and then reuse it somewhere further down the line. They're also useful when we get into the realms of dynamic pipeline generation, which I'll show you in due course. We can download artifacts in the UI itself from a number of different locations. So on the pipelines page itself, if you look at your pipeline, you will have a download button on the right-hand side, and you'll see this as we go through. And then you can download artifacts that have been created as part of that pipeline. We can also go to the jobs page itself and select a job that occurred as part of the CI pipeline and download artifacts from that for specific jobs. We can also look at the artifact browser in a job and see what is actually included in those. So there's a number of ways in which we can download those things, and there's also a number of ways in which we can see what's inside those as well. So what we're going to do now, folks, let me just change my screens around slightly. We're going to jump in and have a look at a template and artifacts lab. Now, the reason we're going to do this, and if I just show you what the plan is to get you kind of hands-on with doing includes, first of all, and also get you hands-on with understanding stuff about overriding different templates that already exist. So if I just plot that on the left and this on the right, I'll take you through what we're going to be doing first of all and show you some bits that are interesting on there as well. So first of all, we're going to be in this lab here. So this templates and artifacts is the one that we're in. I've gone in via the workspaces course location. If you're in the issues, that's fine. They're all the same. The first thing that this lab does is it will go into something called root cause analysis. Now, we've already mentioned so far Duo. Duo, as a reminder, is the AI offering and features that we have across different stages of the SDLC build pipeline inside GitLab, as well as doing things like code creation. We can also use Duo for things like analyzing how well our pipelines jobs performed. Now, this is quite a cool feature. So the first thing that you folks are going to be doing is having a quick look at root cause analysis. Let me just show you an example here. So in this particular job that ran, if I just go to the pipeline itself, this is the one who should look similar to what you folks have up and running now. Here's my super fast test. If I go into this, I've got, of course, a whole load of information that's been logged to the console here from the job. However, what if I'm struggling to actually understand what's going on here? So I can use this button at the top here called root cause analysis. I can click generate root cause analysis. And then what this should do is go off and tell me that in this case, it's really explicit because we actually did a non-zero exit code from the job, which means that job is going to fail. Our AI functionality has picked that up for us. Other use cases around this involve things like dependencies, libraries haven't been able to be downloaded. So reference libraries from like a Maven file, for example, or something like that can't be found. Or you're using the wrong version of a library, for example. Root cause analysis is really useful for jumping in and finding out what's really gone wrong with a particular job in quite an efficient way. So what you're going to be doing first of all is looking at root cause analysis. The next thing you're going to be doing is getting into the realms of doing includes. So what we'll have in our pipeline itself, if I just go into our pipeline file, if I just go back one, if we go into our file itself, what we'll have is the facility to do an include. And what you folks are going to be doing is just copying and pasting this code. We're going to be bringing in the security SaaS template inside here. And then what you're going to be doing is you're going to be just looking at the editor really and seeing what's going on and having a look at the configuration and the tree that provides as part of the include. And then what you're going to be doing is going to be bringing in more security functionality. So, we've got our pipeline in a state now where we can start bringing in more features. And the way in which we're going to bring in those features is going to be via these includes inside here. So we're going to be bringing in additionally code quality, dependency scanning, SAST, secrets detection, etc. So this is really just to show you how how easy it is to do that. And remember that you're bringing in a template here from GitLab engineering. You're not bringing in local files yet. And then what you're going to be doing is looking at CI/CD components. That's really just looking at the catalog that we have. So as a quick example here, if we're in our pipeline editor, there's going to be a button at the top saying Browse CI/CD catalog. And inside my CI/CD catalog, you'll see the current state of that for GitLab.com. And then you're going to be looking at inheritance to extend the pipeline. So there's a SAST stage. What you're going to be doing is based on your knowledge around our needs keyword, you're basically going to say that you're not going to have this waiting for anything upstream. This is just going to go ahead and do its thing and go and run and do what it needs to do to complete a SaaS job. The next step that we're going to do is we are going to start getting into the realms of using artifacts. So in this particular example, we're going to build our application, and then we are going to store an artifact. In this case, it's going to be the gem file or the log file and the gem file.log file. And what this means is that if subsequent jobs require this, then they can pull them. Then it will be able to obtain it from the artifact repository if need be. In your case, what you're going to be doing is you're going to be running this build job, and then you're going to be able to have a look and see that the artifact, you'll see the artifact browser, but you'll also see that there's a downloadable link, which will then include the gem file that you've got inside there. So what I'll do, I'll let you loose on that one, folks. Let me initially put 5 minutes in it as a timer, but we'll come back and see how we're doing from a timing perspective. And then once we're done, we'll revisit this and we'll just remind ourselves of what we've achieved as part of that lab. So I'll shut up for 5 minutes. I'll put a clock up on the wall, and then hopefully we can reconvene. Don't forget, folks, please use the thumbs up in the chat so we can gauge where you're at and understand what's going on. That's really useful to us. And then we'll see how we're going with time and pace as we go further through this. Right, I'll go on mute for a second. Sort of quick question from Mikhail. You may have found the answer to this one, but there's a question about the tree expanded icon mentioned in step 2. You actually should be in the pipeline editor page. And then when you bring in that template, then you can select the expanded tree from that particular page. I will show you shortly. Why did the clock stop? It's an interesting one. Okay, folks, that was 5 minutes. I kind of sense that we might need a bit more chat. How are folks doing? Is anybody racing through that? If they are, can you give me a thumbs up? Michael, you legend. Okay. Good stuff, folks. So we've got some progress. Give it another couple of minutes or so. Let me just kind of like take you through what happened there. A file, the window. Okay, so let's move on. I'm assuming that you can see my screen. So let's just see what we did there. Bit of a recap. So ultimately, you've got to the point now where you're storing something, this gem lock file, gemfile.lock file, and you should be able to download that where from the actual job itself. You've had a play around here with a job override. So you've actually overridden the SAS job here, and you've basically given some additional information to not depend on anything upstream. And you've included a whole load of code quality scanner type stuff in here as well, which is good, which is what your bosses wanted right at the very beginning of this. So that's a good start. So let's go back to the slides. Just bear with me for a second. We'll move on to the next part here. So you should be seeing something that says child pipelines now. What we're doing now in lap 5 is we're getting a bit more advanced, and we're getting into the realms of, we've talked about composability and modularity with templates. What about composability and modularity with different parts of our application that we're building, for example? So we're going to look at things like child pipelines and how we can use child pipelines to help us build our applications in a more efficient way, but also organize our applications in a more efficient way as well. So depending on what you have and the way in which you're architecting your applications, can drive how you use child pipelines and the sort of techniques that we use and why we do it, and how we can create pipelines on the fly, for example. So this is lap 5, child pipelines. So we've done templates and artifacts, as mentioned. We're now in child pipelines. Now we've demoed the most recent version of our pipeline to our people. They like it. They've been running. They've got security scanners in there. There's other teams now that are out there that have got their own pipelines from their own projects or their own parts of projects, and they're actually really keen on bringing in this functionality. So this is common functionality. This is reuse. Then that's a good thing. So we're going to be setting up a child pipeline in the next lab that we have to make our pipeline better. When we talk about child pipelines, you will also see the term downstream pipeline used as well. And a downstream pipeline can happen in different forms. We can have parent-child pipelines, we can have multi-project pipelines, we can have dynamically generated pipelines, and we're going to have a look at each of those as we go through. So we can have multi-pipeline CI/CD setups. It allows for the cases where perhaps as a project has evolved over time, it's got its own CI/CD build, or part of a project's got its own CI/CD build that's evolved at a different rate of change to maybe other parts of the project. However, when we build our project, we want those to form part of the whole. So it's possible for us to bring in child pipelines by calling down into what we call nested pipelines, parent-child relationships to build our applications for us. And the classic kind of thing that you see around the use case would be something like a mono repo, for example, where we've got front end, back end, whatever else in there for our different tiers of our application. Over time, maybe they've had their own CI/CD pipelines written by the teams that look after those particular components. However, when we build that app, we want to build it as an entire thing, so we can bring in the front end, the back end, and whatever else we need to bring in as part of the build. We don't have to start going around changing, existing CI files. We can reuse what's already there. So we can have the child pipeline dependent on results, or we can generate YAML from the parent pipeline. And this is more in the realms of what we call dynamic pipelines, where we can really just create a job on the fly and then call that from a downstream pipeline that we have. Other kind of cases that we have, so the parent-child one there is really the one that I mentioned. So the classic case there is a mono repo. That's where pipelines exist in the same project itself. So we've got a big monolithic application with front end, back end, business logic tier, whatever you want to call it. They've all got their own different CI build files. What we can then do is we can then call out from an overarching pipeline to call those call those pipelines as part of our main build. When we do a parent-child relationship build with inside the same project, we're really passing on the context of the project in which we're in. So the project that the build's being run from, the ref, be it the branch or the tag that we're running with, and the commit char, and some other bits and pieces. And then when we run that with inside our child pipeline, the result of that doesn't directly overrule the status of the branch or the ref branch or tag that the pipeline runs against. However, what we can do with these is configure a a parent pipeline to fall over if a child pipeline doesn't run successfully, for example. And there's a keyword that you folks will be seeing shortly that enable us to do that. The limitations of parent-child are that we can go at the very most to 2 child pipelines. So we can spawn a pipeline and then spawn another pipeline off that pipeline, but then we can't go any deeper than that. So parent-child, think monolithic applications. Multi-project, think more in terms of maybe having like a microservices architecture where you've got absolutely independent projects that have evolved at their own different rates of change. They've got their own code base, they've got their own CI/CD in there, they've got their own testing mechanisms, et cetera, et cetera. However, when we want to build something that includes a number of these different components, how can we do that? So we can call a build file, a build pipeline from another pipeline by basically referencing the project that the GitLab CI file lives in. Now the rules here really are around triggering other pipelines that we have. In parent-child, there was much more a case of moving context and passing our context to our child pipeline. In multi-project, think more in terms of like, these are black box things that we talk to. We don't really pass much information about where the pipeline is called from. It is possible to configure some attributes that drive that behavior, but by default, the multi-project pipeline that's serving the calling pipeline doesn't have an awful lot of information about where it's being called from. The result of the pipeline in the multi-project, where the CI lives in the multi-project, i.e. the pipeline that is being called, the result of that is only really kind of local to that project itself. Because it doesn't know about the calling parent project, it really can't pass anything useful back to that parent project. So they're independent. However, there's no real kind of nesting limits on these things. But the easy way to think about this, where to go with this is parent-child, you're in the same project. For whatever reason, those CI files live in that same project. Multi-project, definitely, distributed different projects, within GitLab. So we have rules and child pipelines as well. So it's possible for us to get creative, and we can make changes to the current results of the pipeline itself. So there are certain rules and certain variables even that are passed down to us. So we can get a CI pipeline source, which is like a system variable that we have. If it's a pipeline, in that case, job one's going to echo that the job runs in a multi-project pipeline only. If it's a merge request event, it's only going to run in a merge request event pipeline. And the third one there is that if it's a multi-project pipeline and a merge request pipeline, then that job 3 is the job that's going to be executing there. So we can get creative with variables as we can with anything, and then we can just drive behavior via the value of those variables. So what we're going to do in this next lab is have a look at child pipelines. Now I'll take you through this in terms of what you're going to be doing before you do it, because that's really useful. The essence of the next workshop is going to be all about what these pipelines are. So child pipelines, we're going to be taking our security code and our security jobs a step further. So what we're going to be doing is extracting our logic around the includes here into a separate file, so it can actually be reused from a calling parent pipeline. So the first thing that you folks are going to be doing is creating a subdirectory and a new file, and the new file is going to contain these includes here. And then the next thing we're going to be doing is linking those pipelines into our existing parent CI file. So one of the things you're going to be doing is actually removing that functionality, moving it into a location where we can make it more common and reusable across different jobs. And then finally, what you're going to be doing is we're going to be adding this extra stage down here called extra security. And inside this job here, this downstream security, job, you'll see that this is in the extra security stage. We're going to be doing an import local. So we're bringing it in from our local project here. And what you're going to be doing is bringing in the file that you just created. So this means that other projects that have got their own build pipelines inside this project could also bring that in if they wanted to in a similar way, and they don't have to replicate any of that logic. So once again, folks, let me put a 5-minute timer up, and then we'll come back and revisit that. There's also some questions that are coming up as well that we'll answer in the meantime. So I'll go back onto mute and I'll stop my video, and then I'll put the clock back up on the screen. Okay, folks, I'm back. I hope that went okay. Again, have we been getting like thumbs up coming through from folks? Do okay. We've had some questions in Q&A, which I'll address shortly, but are people getting through okay with those? Okay, nice one. So let's just address a couple of questions that we had in Q&A. So um, Michael asked about the advantages of using this particular mechanism of doing the include as opposed to what we've done before. Um, in this particular example, what we're really doing is just putting something into a common location where it can actually be reused elsewhere. So it's a way of in this particular case, we wanted to move our security functionality into a different pipeline that can be called from a parent pipeline. So all we did here is just move all this out into a separate file and then trigger a downstream pipeline that includes those security features. And that's not the only way you could do this. You could, of course, you could have a template that already includes these if you want to. That's one way of doing it. But think about this example as just a way of showing you syntactically how to do it and how parents and childs talk to each other and execute each other, for example. When we're in the realms of security, whilst we're here, by the way, there's other ways of bringing security scans into builds via security policies, etc. But that's on another course. There's another question around refs. So what was a ref? It probably has been answered already, but generally it's a way in which we can reference a commit. So it's a pointer to a commit, and that could be a tag, it could be a branch, and it's a way of us internally having a user-friendly alias for a commit hash. So when we have our parent-child builds, when something happens within a CI, within a child's build, it doesn't affect the commit ref, if you like, if anything happened to it. And the same goes for the commit ref in a multi-module project where that commit ref is essentially inside the project itself, and then it can affect the project. You can trigger pipelines on different projects. Okay, let me just move along from this onto the next bit where we looked at child pipelines. The next thing we're going to be doing is going into the realms of something a bit more complicated, a bit more. Another way of doing pipelines is by using what we call dynamic pipelines. And what do we mean by dynamic pipelines? So this is a way in which we can just go back into this slideshow view. This is a way in which we can effectively have like a parent calling pipeline dynamically create the job on the fly. Now that can be done based on things like variable values, any kind of logic that you like to create the job on the fly. And once we've created that job, what we then do is effectively save it as an artifact, and then it can be reused downstream. But first of all, why are we doing it in the context of this particular lab? So now what we want to be able to do is see if we can generate our own security scans through code. So can we actually create a job that creates a downstream job to be consumed? So what we're going to do here is create another demo, and we're going to showcase dynamic pipeline features that we have with inside the platform itself. So first of all, what is a dynamic child pipeline? So we can trigger the pipeline from the YAML that was generated by another job. Really good for dynamic workflows when content needs to change based on values within inside the pipeline or any variables that are being passed in, or anything that we can derive and extract during an upstream job. If that can drive downstream functionality and drive how a job is constructed, then we can do that. We also use our artifact capabilities here to do this. So the flow being that we create the artifact and then we reference that artifact in our downstream jobs. So here's an example of a dynamic pipeline. It's a very basic, simple one here, but we've got a script on the left-hand side. We've got the generate config job. The script is basically going to generate some CI config and then pipe it out to that generate config YAML file. We're going to store this generated config YAML file as an artifact here. limitations on artifacts as an aside of 5 MB. And then what we want to do is trigger a child pipeline using whatever using the job that was created inside that YAML file there. So we then reference that generated config YAML file that was created by that generate config job. So anything that is anything can go inside generate CI, any kind of business logic rules that drive how that looks. Ultimately, we create that, store it, and then use it in a subsequent job. So what you're going to be doing next, we're going to be taking our security things a little bit further, and we are going to be looking at how we can basically create that include on the fly. Now, what we'd do in the CI/CD, if we go through to dynamic pipelines, we're now really going to be moving this pipeline creation. So we're still in the realms of this security and the security jobs that we have. But for demonstration purposes, we're going to be creating a script pipeline YAML creation file. And what this is going to do is store this security config.yaml file. And then we're going to be utilizing that particular security GitLab CI YAML file that we created further downstream. So in this particular case, we're going to be creating a job that actually builds that YAML file in the first place. So we're going to be calling the file, the shell script that we created earlier. We're going to store that in security config, and then what we're going to be doing is we're going to be running that job that we created in a downstream pipeline inside there. So again, in terms of usability, it's okay, but you might want to be doing something which doesn't just include templates. You might want to do something that drives something else within inside your world. So have a start with that. Again, I'll put the 5-minute timer up on the screen. Ask questions, and then if there's anything that we can have a look at when we get back, I'll try and cover those off. Okay, folks, let's come back from that one. A couple of questions of interest came through there. There's a question about why would someone use dynamic pipelines instead of a child pipeline? Think about dynamic pipelines as at any point during your build process, the desired functionality of the child pipeline may be different. So you can't determine it, what it's supposed to be doing until runtime for the actual CI/CD file. So the variables of variable values, certain behaviors at that point in time when that job is run will determine what that looks like and what that dynamic child pipeline looks like. That's one way to think about that. There's a question somebody picked up on. There's a required stage that needs adding to add a stage called dynamic. This is actually a late addition, but we had a stage called dynamic, and then the dynamic security run job is part of that dynamic stage there. Equally, there's this remove the extra security stage that we put in on the previous job. There's also a question around where was Patrick's question? Let me try and find it. To do with variables. So trying to find it. It's disappeared. I can't remember what the actual question was. Patrick, if you got that question, could you type it again in the Q&A box so we can see what you said?
I have it if you want me to respond.
I think I've got, yes, please, Logan. Yeah, go ahead.
Yep. So the question is it possible to pass environment variables to a dynamic pipeline? Short answer is there's no like built-in capabilities, but all the jobs, you can run simple bash from. So you could just run the export new variable name with your actual CI/CD variable, or like someone else mentioned, you could create an end file. Both are valid options.
Brilliant. Thank you very much, Logan. So what we've achieved then, so we've had to play around with pipelines there, different types of pipeline. We've got into the parent-child pipeline mechanism that we have. You've now got a fully functional project that includes the stuff that you've done, hopefully. If you haven't completed it yet, don't worry, you've still got the workspaces available to you. I'm not going to spend too much time on transferring the project. You can do that as in your own time if you want to take the project and put it elsewhere. What we'll do, first of all, really to kind of finish up is come to a conclusion here, recap on what we've done, and then we've got some time for additional Q&A at the end if anybody has any questions. And if you do have them, please put them into the Q&A box as opposed to the actual chat itself. In conclusion, here we've gone through a fair amount of stuff today. Gabriella took you through setting up the lab, starting pipelines, executing pipelines, directed acyclic graphs. We then got into the realms of looking at caching different rules within pipelines to determine when jobs are actually included inside the pipeline itself, what we do on failure and how we actually respond to that. Is it okay? Do we have to stop the build, for example? And then we looked at templates and artifacts and got into the realms of reuse. And this is the kind of the typical use case around this is like a platform team or a DevOps platform team trying to put together some standardization around functionality and templates, and CI/CD components are definitely the way forward there. We've looked at artifacts. We've looked at child pipelines. We actually used different types of child pipelines. We used the parent-child pipeline, and we use a dynamic pipeline, which actually uses an artifact that you've created as well. So we're now at the kind of the end of the labs part and the material that we're going to present to you via slides. We've got some time now for Q&A, so please don't be afraid to ask questions, and we'll try and answer those as we go through. And then when we start running out of questions, we'll wrap it up. So please fire away if you've got any questions.
And just for clarification, we'll be looking in the QA section for any questions coming in.
Yeah.
There is the question that came in. If we replace strategy keyword by need, does it still work?
That's a good question. So strategy, so we can use strategy depends, can't we, from a parent pipeline that drives. So if the child pipeline failed, the parent pipeline would fall over. So that's one way of driving the functionality. Will it still use need though? That's kind of implicit from the parent pipeline that's calling it, I think. If that makes sense. We wouldn't say it's got a dependency on the parent pipeline, for example, because that's just implied because it's being triggered from a parent pipeline.
Hopefully that makes sense. If not, you can open up with another question.
Okay. So we don't have any questions coming through now. I think we've answered the ones there. So there's a question there about how many child can you have? There's a depth of 2 in total. With multi-project pipelines, there's different depths that we can go to. I think the maximum is 11, but don't get yourselves in that mess. I think we recommend that you don't go any deeper than 3. The reason being is that when we do that, we end up kind of like merging pipeline functionality together, and then like if you're trying to track what happened and you've got more than 3 different pipelines, then it becomes a little bit hard to manage and hard to debug and find out what's gone wrong. Okay, so we don't have any more questions coming through.
We did.
Yeah,
sorry, we did just get another question.
Okay.
In dynamic pipelines, if one of the steps failed before creating the YAML file, what is the expected behavior? Do we see a failed stage, or do we not see that part of the pipeline created at all? I can take this one. The actual stage will fail. So like if the steps in creating the job, something goes wrong, etc., on the pipeline, that it will show the red and failed.
Okay, so you don't have to explicitly say that. Could you override that? I guess, couldn't you, with allow failure true or something like that? I don't know.
Yeah, you could.
Yeah, thinking outside the box. Okay, folks, let's leave it there. I hope you found that useful. I hope the pace was good and the content was understandable. And the use cases that we have, kind of relevant to what you've got. Thanks for your questions. Thank you for your time. And we hope to see you on a similar event in the future. So on behalf of myself and the rest of the team, take care. Have a good one. Bye-bye.